Hello everyone. Today I am going to show you how to build the linear regression model using TensorFlow in Spider IDE, that is Python 3.6. I have used Spider IDE as my platform to build the machine learning models. So, I am building the linear regression model to predict the relationship between the two features, which shows linear impact with respect to different species of flowers, and predicting the results of the test data by determining the error rate and minimizing the loss generated. What is linear regression? Linear regression is a linear approach for modeling the relationship between a scalar-dependent variable y and one or more explanatory variables. Linear regression is the most basic type of regression and commonly used predictive analysis. The case of one explanatory variable is called simple linear regression. For more than one explanatory variable, the process is called multiple linear regression. For completing this process, we need to have some prerequisites. They are JDK, Spider IDE, Python version 3.6, 64-bit version, TensorFlow package. So, I am importing the dataset by name, iris, from the library, sklearn, where you can see the data and its attributes, total samples, number of classes or species of flowers. This is the iris dataset, with images of the species of flowers, and the relevant data parameters. In this scenario, I am considering petal width and sepal length as two features which has a potential to produce linear impact on the prediction. Now, open the Spider IDE and you can see the initial step starts with importing the packages that are required for building the code. I have used matplotlib library for plotting the graphs, numpy to build arrays, TensorFlow for building the model using tensors. To import the data, create a variable by name iris, and call the dataset from sklearn by using datasets.load_iris. Classify the data into features and labels, where label is the target variable, which is used for the prediction, based on the feature variables. So here I have considered petal width as a feature and sepal length as a label. Features data is stored in the object, x_vals, and labeled data is stored in the object, y_vals. Since the model we are building is a supervised model, we are splitting the data into train set and test set. So, 80% of the data is assigned to the train set and 20% is assigned to the test set. The model is built using the train set data, and further the model performance is tested based on the test data. For each train set and test set, the featured data and labeled data is taken separately into the objects like x_vals_train, x_vals_test, y_vals_train, y_vals_test for using them in further computations. The shaping of array elements is very crucial while working with tensors. To facilitate that, I have reshaped the tensors with a shape 1 by using function reshape 1, 1. Now, create the placeholders and variables, and set up the learning rate of the model, and batch size, through which the computations of prediction occurs. So, the learning is set to be 0.05, and batch size is 25. Then create placeholders for the feature, x_data and label, y_target, providing proper shape as none, 1. None here represents that you can feed a number of rows to the placeholder. Next, create a session object, which encapsulates the environment in which all the operations are executed and tensor objects are evaluated, and graphs can be launched. So, the ses is the object we have created, and call the object by using the function tf.session. Now initiate the model building process by building the logistic functions for data computations. First, linear function is created as tf.add, tf.matmul, x_data, a, b, and assigned to the object model_output. Here the variables a, b are the slope and intercept values of the linear function. The feature data is multiplied with the intercept variable and the resultant is added with the constant variable in order to obtain the output results. Next, build a loss function which estimates the error value between the predicted and actual measurement, and it is written as loss equals tf.reduce_mean, tf.square, y_target, model_output. Next, in order to optimize the error value on the given trained data, gradient descent optimizer function is used, which takes the error value and adjusts the predicted values with respect to the variables a, b. The resultant is stored in the object my_opt and it is written as my_opt equals tf.train.gradient descent optimizer, learning_rate. Now, we apply this function to the loss object where the error obtained from the loss function is minimized and adjusts the slope and intercept values and calculates linear model for every iteration we provide with respect to the data values. The function is written as train_step equals my_opt.minimize loss. Now, we will estimate the residual losses on the actual data, and it is written as residuals equals model_output minus y_target. Next, in order to utilize the variables you have created, first you need to initialize the variables. To initialize all the variables in one go, call tf.global_variables_initializer, assigned to the object init which needs to be started, by using ses.run, init. Next, you need to create the interactive scalars and histograms that are accessible in the Tensor board. It is a device where you could monitor or visualize the predicted results and the estimates of error analysis. In order to access histogram and scalars in the Tensor board, a summary needs to be generated. So, for that I am taking all the summary functions and data using summary_op equals tf.summary.merge_all. Now we need to feed the data into the train and test set utilizing the placeholders, and the initialized variables are used to perform linear computations and calculates the error rate with respect to slope and intercept of the linear model. So initially, create one list object named as loss_vic. This object is utilized in the computations to append the results that are generated from the loss and predicted functions and further used for plotting the graphs. As you can see, a for loop is created providing the iteration range as 500, and the new objects are created to access the feeding data, with respect to the batch size, by name rand_index, rand_x and rand_y. All the functions are called inside the loop, such as loss function, residual loss, and summary function of histogram, and scalars, and provided the train and test data is fed for the computation by the running the session using ses.run. For every iteration a record will be inserted from the train and test data, and all the logarithmic computations are performed and results are appended into loss_vic. Now, create a function to find the accuracy of the model. So I have performed two operations. One is subtraction to find the difference between the predicted value and the actual value. Then, perform division operation with resultant output and the actual value. Now, I will call those functions in the loop and feed the data to perform subtraction and division operations. For every output of division obtained, if the output is greater than or equal to 0, then it is subtracted from 1, else the output is added with 1 and the mean of the resultant output is calculated, which is called as the accuracy of the model. For every iteration of the loop, the results obtained are stored in the event file, which is accessed by the Tensor board for developing the computational graphs, and it is done by calling the function as writer equals tf.summary.filewriter, folder location, ses.graph. Let us execute the code now and you will find the variables a, b, train loss, test loss, absolute mean square loss difference are displayed in the output console. You will find the outputs of slope as a and constant as b, then train loss and test loss for every iteration, and finally the accuracy of the model for each iteration is shown. This event file is stored in a physical location by creating a temp folder in the local C drive within which a folder by name linear_logs. Now, with the generated results, linear regression plot and loss per generation graph is plotted. You can visualize the linear plot where the red linear line is shown as a best fit line with respect to the data points and the data values are linearly distributed along the best fit line. You can visualize the graph in the console for the loss generation for each iteration where the train loss and test loss is gradually decreased as per the gradient descent optimizer. Now go to the location where you have file location which you have specified in file writer function as shown and copy the location. Open command prompt and run the command as shown tensor board log dir/temp/tensor logs/linear_logs port 6060. A portal address is generated to access tensor board which access the event files that are generated in the given file location and it is shown as E123PC:6060. Open the web browser and access the portal and you can find the tensor board with all dashboards. You can monitor the loss rate in the interactive scalars where the error rate has got gradually decreased from 0.263 to 0.1772. With further improvements and modifications in the data, the error rate can be improvised. Now you can see the computational graphs where you can monitor all the operation nodes with respect to the variables and mathematical functions developed for computations. You can also monitor the trained data and residual losses in distributions and also in the histograms which shows the gradual increase or decrease of the error levels. This completed the step-by-step procedure of building the linear regression model using TensorFlow. That's all for this video. For any queries please reach us at vj.ready@sangam.ai.